Okay, hi, this is Tim from Tiger Astronomy, and I just need to work on a small modification to my quadcopter that I'm developing. And this is based on a design called the Crossfire 2, which is on Thingiverse. And at this point, the arms that you see here are the original arms used on the Crossfire 2, and pretty much everything else I've redesigned. So the designs diverged quite a bit from Crossfire for various reasons. The Crossfire is a good design. It's a little bit dated in terms of flight components, so I've updated mine to use a 3030 flight stack, which I'm running iNav on. And I put out a video earlier today showing a test flight of the drone, of the quadcopter, and one of the problems I had with it was that the battery tray, which is this part here in the drawing, let's zoom in here, this part here, and the bottom tray, this white part, is attached to the rest of the frame. Now you can see here there's no attachment, and that's because it uses little plasticky, spongy vibration dampening balls to sort of hang it, to suspend it in a way in which it's slightly springy. And those are made of a silicone rubber type of substance, and they go in these holes, these large holes, with a counter bore, and you just kind of squeeze them through and they hang on, and then there's a hole through the middle, and there's a plastic pin that goes through the middle, and that's called an anti-drop pin, and the pin has a sort of barb on the end, and there's a little washer clip thing that goes over that and it's supposed to not come off. So the idea is that if your drone gets jostled, it can't pull the grommets out and drop the battery and anything that's attached to the battery tray. Now, I found that to be not a very good design. Now, I don't know if it's just the way I'm doing it, but I found that those pins let go all too easily, and I would rather at this point just put screws in, have the thing solidly mounted, and be confident it's not going to fall off in flight. So what I plan to do is develop some cylinders that fit in these recesses instead of the vibration dampening grommets, and join everything together rigidly. Okay, so how do we get started? Now I'm only going to join the 4 corner holes. I'm not going to join these because these are directly underneath the flight controller electronics, bolts here in these 4 little holes, and so these are right underneath the flight controller, and so I don't want there to be any possibility of the drone landing heavily and pushing a screw right up through the flight controller and breaking the electronics, so that would be bad. So the primary footprint for this design is taken from the baseboard here. So I'm going to turn off the components I don't need, which is, okay, so we don't need to see the top plate, we don't actually need to see the base plate really, but we'll come back to that. We don't need to see the camera mount, the VTX mount, the antenna mount, the GPS cover, the arms, or the battery tray for the time being. So here is our base plate, and I actually want to disable the solid bodies there and just look at the sketch, and the sketch is why am I not seeing the sketch? I think that's because that's up here. Yeah, footprint, there we go. Okay, so this is the main sketch that drives all the dimensions, and one of the things we've got on here is construction lines where these vibration dampening grommets go. So what I'm going to do, I'm going to okay, so from this sketch, let's just turn the body back on, the top plate on. Okay, now the sketch is on the, not the top plate, the base plate. Not the top plate, the base plate body's on. Okay, now as you can see, the sketch is on the top. I don't know if that's clear, but the sketch is on the top surface of the base plate. So let's turn the base plate off again. There we go. So what we can actually do is just begin extruding from this stretch, I think, from this sketch. Okay. So let's try it and see what happens. So it's Q for push-pull. And we can't. Okay, let's stop this and let's go to the battery tray. And let's look at the, right, we are seeing the sketch for the battery tray. And that's on the base. All right. Okay, so all right then. So let's actually create a new component underneath the battery tray. We've got okay, new component. And we are going to call this rigid mounts. Okay, and then we can we can probably use the features that are already here. Can I extrude? No, okay, I wasn't going to draw them because we're in a new component. Let's cancel that. All right, so we're gonna have to create a new sketch, and we will pick up in our new sketch. We're going to draw it on the the base of the battery tray, and we will pick up these points here, which are referenced from the battery tray sketch, and we will make a circle that is of diameter. Now we've got okay, grommet flange diameter. I'm using parametric design here, so these are all variables that I can call on. So So that gives us a circle of the right diameter to perfectly fill that hole, and that's great for CAD, but we're 3D printing, so excuse me. We're 3D printing, so we have to leave a little bit of clearance here, otherwise the part will most likely come out oversized. So for parts that have to tightly fit together, I have two variables, gap fit and gap slide, which set my printer tolerance. And so if we minus gap fit, in fact I'm going to make it gap slide. Gap slide, that's about 0.3 millimeters, and that takes that off the diameter. So I might even want to multiply that by 2 to get it off of the radius. Times 2. Let's see what that comes out like. Okay, and now you can see that this measurement here is now labelled fx, which means it's a function, and the value of the result of that function is 14.4 millimeters. And if we zoom in a bit, you can see that it's left a little gap here. Okay, and then the inside part of that cylinder needs to pass up through this hole. So we'll do a similar trick there. We will, starting from the center point here, and we want the diameter of that to be the what did I just do? We want the grommet hole diameter minus gap slide times 2. Okay, and you can see that's offset that from the diameter a little bit. Of the diameter of the hole now is slightly greater than the diameter of the part we will print, which should mean there's enough clearance to push it through. And then we want to put an M3 bolt through the middle. I'm actually going to do that a little bit later because I want to use a hole with a counter bore to do that. So we will first of all extrude. Let's finish the sketch. Okay, I'm going to name the sketch. I like to name my sketches because otherwise you can't figure out what they do later. So this is going to be the rigid mount plan or footprint. Let's call it footprint. Okay, and now I'm going to extrude that part of the sketch, and I'm going to extrude that by a distance of actually I'm not going to extrude it there's a parameter somewhere that sets that depth, but actually what we'll do is instead of extruding a distance, we'll extrude to an object, and then we can pick the bottom of that hole, and that should, with a little bit of luck, yeah, to object 1 selected. And it's kind of difficult to see what's happening here. So let's turn off the battery tray solid body so we can see where we are. And there we go, look. So we've got like a washer shape. So that's exactly what we wanted. And then let's go back onto the bottom. And now I want to extrude the center part of that. Where's the sketch gone? Fusion annoyingly turns the sketch off as soon as you extrude anything. So we want to extrude that by a distance equal to I've got a parameter for this. We've got base plate thickness, that might come into it in a minute. So we want, let's just have a look and see if I can find the parameter. Base plate thickness, arm, flight stack, grommet hole damage, grommet fund GPS, FPV, M3 clearance hole diameter. We'll need that in a minute. All right. There is a this sketch is on an offset plane, so let's look for the origin. There is a, up here, improved airframe. Okay, now somewhere there is an offset plane that sets how far down that tray hangs below the main body, and I don't see it at the moment. There's an offset plane, but that's probably not it. Maybe that's it. Oh, there we go. There we go. Alright, so that offset plane uses, just uses 14.5 millimeter. Okay, so let's create a parameter for that. So we're going to create a new user parameter. Okay, we're going to say battery tray offset, and that will be 14.5 millimeters. Okay, and that is distance from base of base plate to top of battery tray. Okay. And then we can actually edit that feature and make sure, it's minus, it's minus, okay, so minus battery tray offset. Okay, and right, so that should result in no change, except now I've used a parameter to space the base plate and the battery tray. I can then use the same parameter to take my, okay, where are we? we want this thing, not that thing, this thing here. Okay, so we want to push pull that face there. So let's go ahead and select that, and we want that to be battery tray offset. What? The object that you are... No, don't fade away, I'm trying to read you. The object you are creating is not visible. Okay, yeah, I know that. So that's because I've turned off the battery tray so I can see what I'm doing. There we go. So we want that to be the tray offset. Oh, that plane actually goes to the base of the battery tray, so that's an error in that comment I made. And then we want that to be battery tray offset plus the base plate thickness, because it has to go through the base plate, plus base plate thickness. Okay. And for reasons that will become clear later, I'm only going to go halfway, so I'm going to divide that by 2. So we need to put brackets around that, because it does evaluate expressions in correct mathematical order. So we'll have to do that addition first and then divide the whole lot by 2. Okay, so only halfway. Right. And then we want a hole through that which is big enough to take an M3 screw or bolt or nut. Okay, so we're going to use the hole command, and we will put the hole there on the sketch point, and actually we want it to go to the top of that body there. Okay, and we want it to have a counter bore, and we want it to be we want the counter bore to be big enough to take a nylock nut. Okay, and I happen to have on my desk a box of nylock nuts, and I will take one out and measure it with calipers across the diagonal of the point so that I get the largest measurement, and that comes out to about 6.1, oh, hold on, that's really difficult to measure with good accuracy. Yeah, it looks like that's about 6.1, so we'll call it 6.2. I'll tell you what, we'll call it 6.1 plus 2 times gap slide. Okay, so that counter bore needs to be 6.1 plus 2 times gap slide. Okay, there we go. And the counterboard depth, I've put the nut away, I needed to measure the height as well. Let's get it back out. Okay, the height of a nylock nut is 3.96 millimeters, so let's call that 4, which is close enough for government work. So we'll call that the height here is 4 millimeters, and then the now oh, and the width is M3 clearance hole diameter. There we go. Now, why's that disappeared? Two. Let's say all. Okay, there we go. That's what we want. Okay, so we want our hole to be counterboard, big enough to take a nylock nut, and then only thing is I'm worried that's going to be done near as big as the cylinder itself. Is that going to leave us? Okay, let's make it and then measure it and see what we get. So we'll say okay. And yeah, there's really not much meat there, is there? There is not much meat left there. Okay, what we'll do is we'll change the design while only allow enough space for the head of an M3 bolt and not the nylock nut. Let's see how big that needs to be. It's M3 bolt here. And that is 5.32. 5.33, 5. That's not very round. 5.32, 5.4, 5.32. It's 5.32. That's fairly consistent. Okay, 5.32. 5.32. So let's edit that feature. 5.32. So instead of being 6.1, that's going to be 5.32. And we'll only allow 1 times gap slide, which will make it a bit tighter fit, but that's okay because it will screw in. Okay, and then the depth of that which will give us a bit more strength again. If we reduce the depth of that needs to be actually 3 millimeters. In fact, 3 millimeters. So we can take a millimeter off of that as well. Okay. Oh, no target body found. Now what have we done? Edit feature. Oh, it's back. There's something a bit screwy about this whole command in Fusion 360. It sometimes loses track of the body you're trying to cut, I've noticed. So I just literally edited it and said OK without changing anything, and now it's worked. Huh. So yeah, right. So let's just do a section analysis on that, because I want to see what shape we've got in there. So section analysis on this face here. Oh no, that's not what I wanted. Cancel. Section analysis on this face here, and then we can. That's still not what I wanted. Okay, perhaps what I need to do is do a section analysis on this face here. No, that's still not what I wanted. Okay, I want to cut a slice through it so I can see the inside shape. Okay, inspect, section analysis. Okay, let's do it on this front face. That's pretty unambiguous. There we go. And then we can slide that in till it's halfway through that shape. And ooh, you can see there now how very little material there is there, which is a bit of a concern, really. That is a bit of a concern. Is that yeah, that's as good as it gets too. I was trying to avoid having to reprint the bottom plate and the battery tray, if reasonably possible. But this here is quite potentially weak. I didn't really want to have the bolt sitting proud, because the battery's got to sit there and they'll sort of foul on the battery. What else could we do? Reduce the clearance here, which I don't think is a great idea. Right, what are we looking at? Oh. Maybe I'll have to use M2 screws. Let's have a look and see if I've got any. I do have M2 screws, but they're tiny, tiny. And I don't think I have any long enough. So let me measure. Okay, I have the battery tray, the actual physical battery tray that I made earlier in my hand, and I'm looking at whether the battery would fit between the screws, and the conclusion I'm coming to is no, it doesn't. So I do actually need to recess these screws. I don't think I can live with that. I guess I could ream those holes out. Yeah, that would work. So how big are those holes? Those holes are diameter 8.5 millimeters. I guess I could widen those out a bit, and we could take a millimeter. Yeah, okay. So let's say let's have a look at our parameters here, and there's a grommet. I thought there was a grommet hole diameter. Okay, so that's 8.5. So let's make that 9.5. Wait for it to recalculate. Now what? Cowboy routing and weight reduction. Now I've got an extrusion problem. Oh, fillet problem. Okay, no worries, we'll fix that. So let's turn off that section analysis, and let's edit this. Where are we? I see. Okay. There is a. All right. So this is ruined the. I don't know why. It's ruined that fillet because. Extrude hasn't happened. Okay, let's undo that. and to change parameters. It's getting like doing 3D modelling is getting a bit like coding, where you get bugs and you have to debug them. And well, that's alright, because I'm a programmer. So I can do that. So we want to turn that analysis off. What's going on? Okay, we want to turn that analysis. There we go. Now that's the shape that should be. Now that must mean that that is picking up on some part of that whole geometry somehow. So let's have a look at that. It was the battery tray. It was the gimbal mount that was the problem, this part here. So let's go into the gimbal mount. And it was that fillet there that caused a problem. And the reason that caused a problem is because that extrude never happened. And the reason that extrude never happened is because that extrude never happened. Because goodness knows why. Because apparently that's picking up on that hole. Okay, so we edit that sketch. And oh yeah, see, now that's okay, it's obvious now why that's happened. It's because that sketch has referenced off of this hole diameter. So ideally we would pick up, okay, so let's project that line into the sketch, and then we will did that not work? We will unproject what? Stop it. Okay, so we will. Right, we've got a coincidence constraint there. We want to get rid of. Let's get rid of the solid body of the battery tray. Okay, so we want to get rid of that coincidence constraint. And then I can move that point. I can move that point, he says. Right, that should probably be coincident. That should probably be coincident with that. Ooh, oy vey. That can go away because we don't want that. Okay, and then that should move. Ooh. Alright. Let's delete that segment. That should be coincident with that. And, ooh. That's not quite what I wanted. Well, this is turning out to be a much trickier job than I expected, because I'm having to fix problems I've created in earlier sketches. So there's a tangent constraint here to that line, and I don't understand why that line isn't the same height as that line. That should be... Okay, so let's delete this. Okay, that line should be horizontal, and that point there should be coincident with that point there. There we go. And then let's where was that? That line we projected doesn't seem to have projected at all. So let's project it again. Okay. Okay, now we have a point here that we can use. Okay, good. And so we look at that from the front, so we can now say that that point there, yeah, that point there should be coincident with that point. No, that didn't work. Right, what we do then is we draw a construction line. Okay, construction line from that point straight up. Okay, now that's automatically added a perpendicular constraint there, which is good. And so now what we want to just do is make that point there coincident with that line. There we go. And now we have fixed that sketch problem. So we can finish the sketch. Okay, and then that extrude edit feature, right, extrudes that shape across there like that. There we go. Okay, there we go. And then that extrude, I don't know why that's lost its feature, but that extrude is supposed to pull that circle yeah, that circle. Let's just reselect that. Profiles. Come on. Let's try it from this side. Yeah, there you go. That circle, solid disc, and that guy. Okay, it's meant to pull that. It's meant to pull that from that face there. Hello. Did I get the right extrude? That's what it's meant to do, is cut that shape out of there. But let's go with offset. No. Okay, I'm just trying to see if the... Alright, I'm going to cancel this because I can't see what's going on. Right, now. Okay, so what I was looking for is that this face should have been extruded a few millimeters, and it has been. So we need to... It just looks like the starting point's wrong. So that extrude there has worked. And then this extrude here hasn't. Or it sort of has. So edit feature. And it should have started from... Can't get to the object. It's a bit... Alright, so it's supposed to... Let's pull from... There. There we go. And then it's to... Right, so it starts from that object. Have I not selected it? I thought I had. Yeah. All right. So let's start it from object. That's it. And then it goes to another object, and the object is that point there. There we go. And it should have included... Oh, yeah, we're cutting. So, okay. Why haven't I got... Ooh, unhappy face. Oh dear. Alright, so that extrude... extrude needs fixing as well. Okay, not a problem. That's all correct. That's all correct. But it shouldn't include those. Okay. All right, let's roll back the timeline because there's some weird problem here. All right, now we were missing one slot. One of the nice things in Fusion 360 is you've got this timeline. You can just roll time back, and then so we've fixed that extrude, and then we can go forward in time and see what this extrude does, and that extrudes the shell of that feature. That's all good. And then we have another sketch, and then we extrude that shape there. Okay, I see what the problem is. And in extruding that shape, we have blocked up those bottom holes, and that shouldn't have happened. So it's this extrude here that needs fixing. And it's supposed to start from it's the sketch that's wrong. The sketch is not supposed to go all the way to the back. So that extrude should not have extruded that part. There we go. That's our problem. And then if we roll the timeline forward, there we go. Perfect. And then put the fillet in. The fillet no longer has an error. Okay. Oh. Now that's interesting. Oh no, that's correct. That's correct. All right. So, where were we? We're trying to get our rigid connectors going, weren't we? So, in order to do that, where have they gone? See, that component's disappeared now, and I think that's because I rolled the timeline back to a point before it existed. So let's just... There we go. Okay. Oh good, that's all working. That's all working, that's good. And... Okay, so we've got that guy. And now we want to extrude... No, we don't. We want a new component, because what we've got there is the bottom half of the thing I'm making. Alright, so rigid mount. Rigid mount. Recessed M3 bolt. And we have a new component. And that's going to be rigid, what did I call it? Rigid mount flush. Okay, now to get the rigid mount flush, we would like to can I extrude off that? Push pull. No, because it's a different component, so I need to. I wonder if I can move that up to the parent component. Let's try it. Error. Yeah, it doesn't like me doing that. It's refused to allow me to do that. Okay, no worries. Will it extrude down from... Okay, so... It's a damn shame, really. Come on. Let me move that sketch up there. Warning. Detect some position feature may result downstream features fail after restructure. Obviously a student of English. May fail after restructure. I would have done this differently if I'd known when I started. Alright, let's just start another sketch on top of that guy there. We will I think we can pick up those features, so we'll just start with the exact same features. Can we do that? No, apparently not. Hang on. I think I just made a construction line, didn't I? I'm not sure whether I actually just made those lines or... Let's undo that. Not happy. In Fusion 360 you're supposed to constrain your sketches, so when I draw a circle from that centre point out to there and click OK, you can see that circle's in blue, which means it's not constrained. So in order to get that constrained, I need to actually fix the diameter. So geez, I don't know where I am now. Okay, right, let's start that sketch again. It's annoying that I can't just use the sketch I've already done. But alright, we are where we are, right? So let's project that circle on that circle and that centre point. Let's say OK. And now we've got purple projected features that I should be able to No, it's not constrained. Okay. Grr. All right. So it was I'll work this out in a minute. It will be great. Right, center diameter circle. Circle from there to there. Okay, so it was grommet hole diameter. Grommet hole diameter minus gap slide. I can't remember what we did. Gap slide times 2, I think. Doesn't look right. Hole diameter minus gap slide times 2. That's better. And then now you can see, hopefully, that line is, it's hard to see, but it is constrained. Oh, I hope it's constrained. It's we've got a concentric constraint there, and we've got a fixed diameter, so it should be constrained. And so we can do another one. And that was grommet hole diameter. Grommet hole diameter. Grommet hole diameter. Minus gap slide. Not grommet. I am not making a very good job of this. M3. Oh. Now it's frozen. Are you going to come back, Fusion 360? Oh, okay. M3, there we go. M3 clearance hole diameter. That's what I want. There we go. And then we want a third one, third circle, which is this big guy here, which is the grommet flange diameter minus the There's plenty to play with here, so we can say gap slide times 2. Okay. And then we can start extruding, and we can say finish sketch, and okay, we want to extrude that by battery tray offset plus bottom base plate thickness, yeah, base plate thickness, that's it. All divided by 2. Okay. That looks good. And then we need to, and let's turn the sketch off, which I didn't want it to do. So turn it back on, and then we need to extrude that section there. Not from the profile plane though, but from an object, which is the top of that. And I can't remember. I can't remember how deep it needs to be, but let's call it base plate thickness over 2. And in the other direction, like that. There we go. Alright. Now the reason I've made this in 2 halves is because it has to be assembled, so it has to come in from the top of the base plate and the bottom of the battery plate and meet in the middle, and then everything gets screwed together. And if I made it in one piece, I wouldn't be able to pass it through, so that's why it's in 2 pieces like that. And something seems to be oh no, that's it. Okay, so though that is the peg. Okay, so now if I turn on the base plate, okay, that should sit flush. It's not quite, is it? Let's have a section analysis there. Let's inspect section analysis on that face, and we'll push that back. It's all right though. It's all right. I just hope I get away with this thickness here. It's awfully thin, but it might just be enough. So that is basically my design finished, I think. So we can turn that sketch off again. And that I think okay, let's should probably make a rectangular pattern of those. Let's go up to the battery tray component, and we will start with nothing selected, and we will make a let's look at the top. Those are, yeah. I don't need to. I'm not going to do it for now. I'm just going to leave the one component there. It looks a bit odd in the model, but you know, what are you going to do? We've got another sketch turned on there. Battery tray. Recessed M3. Turn the sketch off. There we go. There we go. Alright, so I'm going to save that. And okay, so what did I do? Added rigid mounting pins for battery tray. Okay, and now I am going to take those two components, so that one and that one, and I'm going to save those as STL files. Oh, it looks like I have to do it separately. Alright. So, save as STL. High poly. Did that ask me? Idiot. Save as STL. Okay, selection. Yeah, it's only going to let me do one at a time. Alright, no worries. Right, rigid mount recessed M3 bolt. And yeah, save as STL. Okay. Rigid mount flush. Save. Okay. And we're done with Fusion 360. We can close that. And we're going to open up Prusa Slicer. This may take a minute. If this works out and the pins fit and they're strong enough and everything, then I'll go back into the model and make another 3 copies and put them in the other position so the model looks balanced. But it's not worth doing it until I know they're going to work. Alright, so we will now bring that in to Prusa Slicer. Crossfire 2, TPL Designs. Okay, rigid mount flush and rigid mount recessed M3 bolt. Open. And there they are, both overlapping on the build plate. So it's just, we didn't get all of that one. That's interesting. We made a washer. Well done us. Okay, so I was a bit quick to quit out of Fusion 360 there, so I'll load that again. while we're waiting, this obviously needs to print the other way up, so we can ask the slicer to put a surface down onto the build plate and then click the one we want. So there's that done. And this one, probably best as it is. Let's say save project. And we can say, let's see if it's in the Prusa folder, rigid mount pins, rigid mount pins, save. Okay, and that's designed, that's set up to print at 0.2mm layer height with a 0.4mm nozzle on an Ender 3 printer, using Sunlu ABS red filament, and on its it knows about Octoprint, so we can send that out to our print server. And we'll be needing 4 sets, so we can right, so we can say we need 4 of those and 4 of those. There we go, line them up. It's a funny way to do it, Prusa Slicer, but there you go, whatever. And just while I'm waiting for Fusion to finish loading, we can look at the sliced output. Now these are obviously wrong at the moment, but we'll reload those in a minute. But estimated print time 26 minutes for the set. And we can slice down through these and see. 3D printing, no, FPV multi-rotor, there we go, it's improved airframe. That guy there. And battery tray. That guy there didn't export in its entirety for some reason. Save as STL. Okay. Overwrite the STL that we made before. Yes, replace it. And then in Prusa Slicer, we should be able to go reload from disk. And it's come out exactly the same. So what's going on there then? Okay. We need to turn off some things we're not interested in. The battery tray body, and try and figure out oh now that's interesting. Well, I'm a bit confounded by that, because I definitely remember putting a recessed hole in that. And it's not in the timeline anymore. So that's all a bit weird. Alright. Let's re-extrude it then. That's totally weird because that one's built on the top of it, and that's just weird. Let's just, before we get too carried away there. There's the hole. There's the extrude that's meant to be. Let's edit that feature. Profiles, one selected. Yeah, that one, that's it. That profile. Yeah, not that one, but definitely that one. Okay, and then the distance is not 2 millimeters, that's the thing. It's not 2 millimeters, it's battery tray offset. Over 2. Warning. Object you're creating is not visible, and that's because there we go. He's back. And the hole's there. Alright, I think we might have recovered that. So let's save that. We repaired rigid mount pin, and so we want recessed M3 bolt. This guy here we want to save as STL. Save as STL. And yep, high poly and everything. Save and overwrite. And then in Prusa Slicer, reload from disk. Reload from disk, where is it? There it is. Come on, don't tell me it's... It's not that I don't believe you anything, but I don't believe you. Reload from disk. It's Actually, it's this thing I want to reload from disk, isn't it? I don't get it. It's still a washer. What's going on? Right, let's hide that one. It's definitely not a washer, dude. Has that got into the wrong component? Ah, yes, now you see what I've done here, I think. No, we're good. I think I have accidentally put these into the wrong place. I wonder if I can... I don't think you can... No. Right. So what I would have to do is... Hi, vey. Okay. So, in this component, I need to extrude battery tray goodness. Okay, we want to turn off the gimbal mount. Where's that? There it is. Right. We want the sketch on. Okay, we want to extrude that. To object. Oh, see now. We want to extrude that to there. Don't believe that worked. Okay, unselect and New object. Right, so we want to go up to. Sometimes it can be difficult to see the thing you want to get to, but it's that face there. There we go. Okay, new body. Now then, and then this guy we need to extrude distance battery tray offset over 2. Alright, hopefully that should, yeah, okay. And I think we need to add the base plate thickness in there. So the distance is battery tray offset. So it's battery tray offset plus base plate thickness, close bracket, all over 2. Okay, and then we need to put a hole. We need to put a hole from that sketch point going up this way. Okay, reverse direction. That's it. And that hole needs to go to, well, let's just say all. And it needs to be counterboard. And I can't remember any of these measurements, of course. So it was... Okay, let's get the calipers out again. Okay, the diameter of an M3 bolt head is 5.32. That was it, 5.32. So 5.32 plus gap slide. And this diameter here is M3 clearance hole diameter. I think it needs to be alright, so now we screwy funny hole feature that doesn't work properly, and the depth of the counter bore needs to be, I believe that was 3mm again, if I'm not mistaken. Let's have a look, see. Yep. 3mm. Okay. And go. And we should be able to turn off the sketch again. Oh, I've lost my mouse. Where's it gone? There it is. We should be able to turn off the sketch, and then under there we should have our part with a hole in it, and we do. So if we now take that, save as STL, high poly count, Save and overwrite, and we'll save that. Let's park Fusion, and we should be able to reload from disk. Yay! Okay, good. And if we preview that, we should be able to figure out okay. Alright, I think we'll get away with that. Alright, so what I'm looking at is the number of perimeters here that we've got to play with when we slice the object, and as you can see, we start from the build plate, and we have the large hole here, which is the recessed M3 bolt head, and then that suddenly reduces there to the M3 clearance hole, and then we start to build up that's actually more decent than I thought. We've always got at least 3 diameters there. That shouldn't be a problem. Doesn't seem to be very tall though. That was the critical point there. I was worried about strength, but three perimeters should be strong enough. So we want a total of 4 of those. So set number of instances to 4 and tidy up. And there we go. Those are our pins. Alright, that's it. We're done. It's way past my bedtime, so I'm going to set the printer up to print these overnight, and we'll see what they look like in the morning. That's me signing out.